You ask your company's AI, how do I reset my password? It fails. The answer is sitting right there in the documentation, but the page says, change your account credentials. Not one word matches. Your AI just got beaten by a synonym. And that failure is why an entire new kind of database had to be invented. By the end of this video, you'll understand the one piece of infrastructure every AI app is built on, and it's not the model, it's the database. Stick around, because once this clicks, RAG, AI agents, and AI with memory all stop being magic. Let's unstitch this. A traditional database, SQL, Postgres, MongoDB, is built for exact matching. You ask, find every order from today, and it finds every order from today. It's brilliant at that. But here's the catch. Exact matching only works when the words match. The moment your user asks, how many days off do I get a year? But your policy says annual leave entitlement, the database shrugs. 0 results. Not because it's dumb, because it was never designed to understand that days off and leave mean the same thing. This is the core limitation. Traditional databases match strings. They don't understand meaning. And that distinction, strings versus meaning, is the entire reason vector databases exist. So how do you teach a machine meaning? You stop storing words and start storing numbers. Stay with me. I promise this is not a math lecture. Here's the mental model. When you hear the word king, your brain doesn't store the letters K-I-N-G. It stores a web of associations: royalty, power, crown, throne. Your brain holds meaning in relationships, not letters. Machine learning does something almost identical. An embedding model takes any piece of text, a word, a sentence, a whole paragraph, and converts it into a list of numbers. Maybe 384 numbers, maybe 1436. That list is called a vector, and here's the magic. These numbers aren't random. They're positioned so that similar meanings land close together. Take 2 sentences that share no words. How do I reset my password? And how do I change my account credentials? Different words, same meaning. The embedding model hands you 2 vectors that are almost identical, sitting right next to each other in space. This is the distinction that confuses almost everyone. So let me make it crystal clear. An LLM, like ChatGPT or Claude, generates text. An embedding model generates vectors. They are different tools for different jobs. You don't ask an LLM to store 1,000,000 documents, and you don't ask an embedding model to write an essay. The embedding model's entire job is text in, numbers out, numbers that capture meaning. Now you have the pieces. The embedding model converts meaning into vectors, and the vector database is the thing that stores those vectors and lets you search them at lightning speed, not by matching words, by measuring distance in space. Here's how it actually works, step by step. First, you take your thousands of documents and split them into small chunks. We'll come back to why that matters. Each chunk gets converted into a vector by the embedding model and stored in the vector database alongside the original text. Now a user asks a question. That question also gets converted into a vector. The database doesn't run a like query. It runs a similarity search. It measures the distance between the question's vector and every stored vector and returns the ones that are closest. That's it. That's the whole trick. Similar meaning becomes small distance between vectors. And because measuring distance is a solved mathematical problem, the database does this across millions of documents in milliseconds. This is the engine behind RAG, Retrieval Augmented Generation. Here's the analogy that makes it click. A normal LLM is a closed-book exam. It can only answer from what it memorized during training. Ask it something specific to your company, or something that happened after its training cutoff, and it hallucinates or says, I don't know. RAG turns it into an open-book exam. You ask the question, the vector database retrieves the most relevant chunks, you hand those chunks to the LLM as context, and the LLM writes a grounded answer. The LLM is the student with great reasoning. The vector database is the textbook. And it's not just chatbots. Spotify recommends songs you've never heard because your listening history is a vector matched against millions of song vectors. Pinterest finds visually similar rooms because an image becomes a vector. Netflix, fraud detection, Google search. The mental model is always the same. convert data into meaning, store the meaning, search by distance. Now, two things every tutorial skips, and they're the reason people build this wrong. First, a vector database does not replace your SQL database. Your Postgres or MongoDB is still the source of truth for orders, customers, payments. The vector database works alongside it, handling the find me similar meaning search. Two tools, two jobs. Second, and this is the mistake I see constantly, chunking matters more than you think. You don't embed a whole document as one giant vector. You split it into chunks. Too big and you lose precision. Too small and you lose context. A solid starting point is 300 to 500 tokens per chunk, with 50 to 100 tokens of overlap, split on sentence boundaries, never in the middle of a word. If you want to build, here's your starting point. Chroma, free, runs on your laptop, perfect for your first RAG prototype, working in under an hour. Qdrant, open source, self-hosted, fast. Pinecone, fully managed, scales automatically, generous free tier. And if you're already on Postgres, pgvector adds vector search without leaving the database you know. Start with Chroma. It's the fastest path from I understand this to I built it. So here's the whole thing in one breath. An embedding model turns meaning into vectors. A vector database stores those vectors and searches by distance. Together, they let AI find information by meaning instead of words, and that's the hidden infrastructure behind RAG, agents, and every AI with memory you've seen. But there's one piece I skipped on purpose: how those embedding models learn to place king near queen in the first place. That's the attention mechanism, the idea that made all of this possible, and it's the next video in this series. So if you want the full picture of how AI actually works, subscribe because that one's coming next. And in the meantime, drop a comment. What did your AI get wrong last? I read every comment.